of summarizing the data, and so as such the summarizations can be done either in the form of tables. So any summary which we are doing on a data, we would be doing either in the form of tables or in the form of diagrams. So we'll typically look at both these mechanisms. If I am doing it in the form of tables, what are the tools that are available with me? If I am doing it in the form of diagrams, what are the tools that are available with me? So to start off, when I am looking at the tables, the first tool that is generally available for everyone is what we call as frequency distribution. Frequency distribution is one of the powerful mechanisms if I am looking at summarizing the data in the form of tables. And what does it mean? It's a simple counting of the number of occurrences of each of the values. For example, I'm taking a small data set. Let's say this is a data set containing some 20 different numbers. Let's say this is about the marks scored by a person out of 15, marks scored by 20 different students out of 15 in one slip test. So if I summarize it in such a way that for each set of marks, how many are there? How many, the statistical word for how many is frequency. So if I say how many got 10, how many got 11, how many 12, 13, 14 and 15. If I can make a table which talks about the number of occurrences of each of the values, I call that as a frequency distribution. So in this case, how many got 10? I have 1, 2 and 3. There are 3 people who got 10, so I would be writing 3 corresponding to it. Then what about 11? 1, 2. Only 2 people got 11 in this group. So I'll write 2 here. Then how about 12? 1, then 2, 3, 4 and 5. 5 people got 12. 13, 1, 2, 3 got 13. And what about 14? 1, 2, 3, 4, 5 got 14. And the remaining 15, 1, 2, only 2 got 15. Now let's try to add up, calling it as total. This total should definitely be equal to the total number of students. So 3 plus 2, 5, 10, 13, 18 and 20. So the total numbers are 20 here. So this particular table, where we are talking of different values which have occurred along with their frequencies, along with the number of occurrences of each of these values, is what we call as a frequency distribution. So this type of table is what we are calling as frequency distribution. And now, for example, here there are only 6 different possibilities: 10, 11, 12, 13, 14, 15. Very simple discrete data, and only 5-6 possibilities are there. So tabulating the data in this format looks much easier. Whereas, assume a scenario where all different values are possible, good number of finite values are possible. Look at this data which I am placing. There are 25 people in this exam. Again, I am trying to denote how much they have scored out of 30 in one exam. There are 25 students in a class. How much did they score out of 30 is what has been tabulated. But this time you see there are not just 6 possible values. We are seeing so many possibilities here. So if I start making a frequency distribution like this, okay, 8 how many are there, 9 how many are there, 10 how many are there, it becomes a big table because right from 8 I have values even up to 27. So there are so many possibilities and my table looks pretty long. So it is in this scenario, especially when I have different number of possibilities, even though it's a discrete data, but if I have good number of outputs coming out, it's better to group them and